Welcome to the lecture of production of automotive components. So this lecture will be talking about RRIM, which is a reinforced reaction injection molding process. So this process is mainly used for making automotive components like bumpers and the plastic panels, the dashboard covers, and also sometimes the floor panels. So all these are made up using this RRIM process, which is quite a new process. So first, before going into RRIM, we'll understand what is RIM, which is reaction injection molding. So reaction injection molding is a process in which two or more liquid intermediates. So there are two liquid polymers. One is isocyanate, other one is polyol. So these two are mixed together, and by the process of high pressure impingement mixing, which means both of it is subjected to very high pressure and they are sent through the pipes in opposite channels, and then when they impinge into each other, they'll polymerize to form a molded part. So advantages in this process include low pressure, low temperature, and use of reactive liquid intermediate. So what we have is isocyanate and polyol. Both of it is a monomer, both together combine to make a polymer. Okay, so A and B, polyol and isocyanate, are continuously circulated under nitrogen blanket, and then these two are combined together under the pressure of a high pressure metering cylinder into a mixing head. So in this mixing head, when the piston is there in the closed position, there is no contact, and when it is open, both these A and B, which is polyol and isocyanate, impinge and form a polymer. So next, talking about the manufacturing process. So this is an alternative to injection and compression molding because of low cost, low surface area components which are not very large. So all this basically reduces the cost by approximately 30% when compared to the other manufacturing processes. And here the process variables are the temperatures of mold and monomer, injection and clamping pressures, material flow rate, and density. So here what we have is better control of these variables, which will lead itself to manufacturing using CAM and robotics. And clamping force basically depends on the material and projected area, but it's very less when compared to that of injection molding. It's just 0.4 megapascal order, which is less compared to that of injection molding. And low injection and clamping forces are because the polymer which we use is basically of low viscosity, and hence vertical machines can be used. And cycle time is approximately, for a 5 kg part, it's like 1 minute. That is a cycle time. And here we also use what is called mold release agent. So mold release agent was used in this manufacturing process, but nowadays what we have is in mold release technology, where inside the mold itself the activating component is released, because of which there is 50% increase in productivity. And to eliminate secondary painting, like instead of having to paint it again, we can make sure that the UV stable pigments can be added to the monomers. Like in polyol and isocyanate itself, you can add these UV stable pigments so that there's no need for a secondary painting. So the component which is like coming out of the mold itself is good enough to be directly sent for processing. So where this is used is in the automotive industry for bumpers, body panels, steering wheels, and fascias. So fascias are nothing but the decorative components in your dashboard. So that is again made using this process RIM. So next we'll go to the reinforced reaction injection molding, RRIM. So this is the next level of reaction injection molding. As you can see, reinforced. So there are reinforcements which are being used and added to the monomers polyol and isocyanate. So what these will do is they'll improve the properties of the resin. They will reduce the shrinkage, thermal expansion, and also increase the stiffness, tensile strength, and tensile elongation. So these are basically milled fibers of flakes that can be added to the resin before they react in the mixing head. And metering is accomplished as usual with high pressure pumps and injection cylinders. The two resin streams enter from opposite sides of mixed chamber under very high pressure, and there will be energy intensive collision, because of which a polymer will be formed. Although the streams are very high pressure, the resulted polymer is basically of low viscosity, and hence it can be easily injected into the mold at a very less pressure, only 345 kilopascal. So polymerization takes place like very quickly, and you don't need any additional heat. So talking about the resins and reinforcement, what we have is the resins are epoxies, polyesters, nylon and polyurethane. So if you see right now, the components that are made, mostly polyurethane material is the predominant resin. That is the important material, which has the flex modulus 170 megapascal to 3.5 gigapascal. So you have the reinforcements, which are hammer milled glass fiber and glass flake. So glass fiber is nothing but the reinforcement, resin is polyurethane. So the variations include what is called structural reaction injection molding. So in this, chopped fiber forms or mats are positioned in the mold cavity, and then you pour the mold, and the reacting resin, it remains liquid long enough to completely fill the mold, and then it penetrates the reinforcing fibers, and then finally it cures. Cures means it thickens and it sets. So finally, talking about the applications of RRIM, it's mainly in the field of transportation, automotive and truck applications, where it's used for the body panels, fascia, bumper beams, pad tire covers, floor pans, and all these are manufactured using RRIM process. And right now, controllable reactivity resins like amide or polyurea is a new trend that enables making larger machines, larger parts, which can even weigh over 100 pounds. So all these is a breakthrough application of reinforced reaction injection molding process, and it is definitely there in the future trend, which market is improving day by day. Thank you.